Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 2, approaches to problem solving for this course, quantitative reasoning. So if you missed the first section 2A, where we addressed the extending unit, where we address the problem, sorry. So we addressed the problem problem solving, obviously. Understand, solve, and explain problems. That was section 2.A. Now we're going to continue with the extending units analysis. So what we're gonna do in this section, especially, is really talking about the US customary system of measurements and the international system of measurements. But like it is really the extensions of unit analysis. We have seen how unit analysis can be used in finding a path to the solutions of a problem. We can do even more if we understand the units that commonly arise in a greater range of situations, right? So, for example, we can use units to help solve practical problems involving energy, density, and concentrations, including the type of problems that opens, the chapter you saw before, right? So what we're gonna do in this situation now, we will turn our attention to understanding the unit for those problems, starting with an overview of the two commonly used systems of standardized units. So there are two of them. At the beginning, there were so many different way people can see units. One of the common units of measures that is foot. You know, it's we said it's 12 inches, but there is a big story behind this, but maybe another time I'll have the chance to explain why it is important that we use 12 inches for 1 foot. But if we turn right now to the most important systems of standardized units we can see in the US, we use in the United States, most of our daily measurements are made with what is often called the English systems of units, but it is more formally known as the US customary system. We can say that the US customary system has roots dating back thousands of years, and its units become standardized in often surprising ways, very important. For example, the modern length of 1 yard was defined by English King Henry I. 1100 to 1135. That's a year he worked. So would decreed it to be the distance from the tip of his nose to the tip of his thumb on his outstretched arm. So that's what he did. We have multiple tables. The tables in that you're gonna see here really summarize the official U.S. customary system, showing a standard unit for length, weight, and volume. Like this table you see right there. Many of you knows that 1 inch is 2.54 centimeter, 1 foot is 12 inches, 1 yard is 3 feet. I think we went over those already. 1 rod is 5.5 yards. I know some of them we don't use all the time, but 1 pound is 16 ounces. Probably that's the most usable value for weight in America, because anytime baby born, they ask you for the weight. In America, we don't say kilo, we said pounds and ounces. Those vehicles, when we say the vehicles weigh 3 tons or 5 tons, we understand what we mean. So 1 miles, in 1 miles in America, you know how many, feet is 1 mile, because 1 miles is 5,280 feet. So we can do that all the time. One furlong is 1/8 of a mile. So many of these, so those of you who cook, you know that one cup, right? So if we take one cup here, as you can see, for one cup, for example, okay, so we can say one cup is 8 fluid ounces. So remember when we say fluid ounces, it's very important. One teaspoon, the 1 tablespoon is 3 teaspoons, right? One quart is 2 pints. One pint is 12, 16 ounces. So those are a few of the measurements we use for volumes. The same way as we talk about ounces and pounds and tons, so we talk about weight, the length. Let's say if you need to drive from point A to point B, let's say you drive from Connecticut, somewhere from Connecticut, let's say you drive from the Nelson, Connecticut to Manhattan, New York. So we said, what is that distance? We don't expect you said that distance is in ounces. You don't expect that distance would be in teaspoon. You don't expect that distance would be in grams, but we would expect those distance would be either, I mean, in the US customary system of measurements, it would be in miles, it would be in feet, might be in yard, right? It would be in centimeter, but not in ounces and pounds, right? Because it all depends on what you do. The same way, if you want to fill up a womb with rice, so that's the volume. If you want to fill up a room with rice, we don't expect you would use measurements like miles or centimeter. You would use like ounces, pounds. You would, I mean, you would use, quart, pint. So that's mostly what we need to do for the volumes. Okay, not really miles or kilometer. All right. So let's do a few examples when we deal with the U.S. customary system of measurements. We can just practice a few of them. So one of the examples we can go over right now. Answer the following questions involving conversions with the U.S. system of measurements, right? U.S. system of measurements. So the Kentucky, this examples is about we can do either A or B or C, but let's do the first one. Let's do A. We said the Kentucky Derby. I mean, those are three exercises. That for us, we have one, we have two, and we have three different exercises. It's not what A apologize for the notation. So let's say for each of these, they are all independent exercises. So the Canterbury, we said that the Canterbury Derby distance is 10 furlongs. So if we have that distance 10 furlongs, so this is a distance, all right? How far is the Canterbury Derby in miles? So the first thing we need to go is check what is one furlong in miles. So we see one furlong in miles is 1/8 of a mile. So one furlong is equal to 1/8 of a mile. So if we want to convert 10 furlongs in miles. So the first thing to do in this case is to take your 10 furlong and you multiply it by 1/8 of a mile. So that's what you need to do. That's as simple as it is. 1/8 of a mile. So that means you're gonna have 10 over 8, and that's would give you when you grab your calculator 1.25 miles, right? Now, the second questions in part A, they said you need to do it in yards. Wow. So, let's see what we're gonna do. We know 10 furlongs is 1.25 yard. Let's see if we have furlongs in yard. No, we don't have furlongs in yard. However, we do have miles in yard. Look, if I have miles in yard, because we said one 1 mile, okay, 1 mile, we said it is 1,760 yard. 1,760 yards, right? So if we know 1 mile, but 10 furlongs is 1.25 miles, and 1 miles is 1,760 yards. All you need to do in this case is taking 1.25 and you multiply it with 1,700, right? You multiply 1,700, okay? Um, 1,760. So if I grab a calculator very quick, I'm pretty sure the answer would be correct. We said, okay, 1.25 times 1,760, and it gives you 2,200 yards, okay? So that would be 2,200 yards. Huh? Other ways you could do it, you could convert your furlongs to feet because they could ask you also to convert that to feet. And you do the same because you know one miles, let's say 1 miles is 5,800 feet. So we could also convert it this way. Now, we can I can do every one of these exercises, or I can leave them for you to enjoy because I like when you enjoy doing some of these on your own. But just in case it's you want to see how would you do C, for example, if I leave B for you for C, let's go over C. For C, it says that what is your average speed in miles per hour and in feet per second if you want 4 miles in 4 minutes, right? So now look at this one. You want 4 miles in 4 minutes. Okay. So remember here, what is your average speed in miles per hour? So you want to know 1 miles per hour, right? Miles per hour. So that's our goal, to do 1 miles per hour. Or what is a miles per hour? So what is hours then? So if you do what we can do in this case is to do a lot of computations. So the first step we can follow through here is to know what would that be in minutes. For example, we know 1 hour is 60 minutes, right? If you know 1 hour is 60 minutes and if you do run a mile in 4 minutes, how many miles you run in 60 minutes then? Right? If you want to know, you do 1 mile in 4 minutes. If you multiply it with 60 minutes that you have in 1 hour, right? So it would give you something. So you know if you run 1 miles in 4 minutes, so in 60 minutes, how many miles would you run? All right, 60 minutes is 1 hour. So you're gonna run 1560 divided by 4 is 15 miles per hour. So that's what you're gonna do in 1 hour, right? Because they said, what is your average speed in miles per hour in foot per second? Oh, they ask you foot per second. Now, I find the number of miles you can run per hour, because if you do 1 miles in 4 minutes, then you can do 15 miles in 1 hour. So if you agree with that first part, we can move forward with the second part. So the second part, how that's work, they ask us to do it in seconds, feet per second. And we know 1 miles in feet, 1 miles in feet is 5,000. Remember, 1 miles in feet is 5,280. So remember, 1 mile is 5,280 feet, right? Now, what we can do, we're doing C. Remember, we're doing C. What we can do here, we know we do 1 miles in 4 minutes, right? If you multiply this, because you know in 1 minute, we have how many seconds? Because we need to convert to seconds, right? We have 60 seconds, all right? And then how many miles, in 1 miles, you have how many feet? Yes. In 1 miles, we do have, no, we're gonna change it. We need to change it because I cannot have miles on the top again, or otherwise it would be multiplied. So let's say we have 5,280 feet in 1 miles. Remember, you need always to have something to cancel out. Remember, here you do 1 miles in 4 minutes. Now let's cancel. We cancel this minute with this minute. We cancel this miles with this miles. Now, as you can see, we're gonna have only feet per second. So 5,280 feet over 4 times 60 seconds. So in this case, when you take the top multiply divided by 4 times 60, 4 times 6 is 24. 5,280 divided by 2,240, it gives you at the end 22 feet per second. I'm hoping this help you to continue using the US customary system of measurements because it's a big table. If you don't understand this table, you can always Google because once you hit, you have two big systems as we state, two big systems we said. We do have, all right. This two big system of standardized units. So we have the US customary system, USCS, and we do have the international one. So if international matrix system. So for the US one, you can always Google it, and probably that's the one you understand. We're gonna go over another examples very quick. For this one, they said in each case, decide which of the two price is the better deal. Usually, I go with one examples, and I let you do some on your own. If we go with A, going with A, we said that you can buy shampoo in a 6 ounces bottle for 3.99, or in a 14 ounces bottle for $9.49. So which one you think is a better deal? So, right? How would you find the one with the better deal? How would you go? Because remember, for A, 6 ounces is for $3.99, right? But you also have a 14 ounces for $9.49. How would you compare these two? It's very important to decide how would you compare it. Do you have an idea? Yes, you need the price per ounces. If you know the price per ounces, it's help you to see clearer. So, for example, if 6 ounces cost $3.99, the price for 1 ounce is you're gonna do 3.99 divided by 6. In a calculator, please grab a calculator. You would realize that the price would be 0.665 dollars per ounces, right? Now let's try for this one. If you take $9.49 over 14 ounces, when you do these divisions, it would give you 0.678 dollars per ounces. So between these two, which one you think is a better deal? Oh, do not take the one that are more expensive because you are the customer. Do not take the one that costs 67 cents. Take the one that costs 66 cents because the 6 ounces is a better deal for the customer. The 6 ounces is the better deal, right? Because you need to make sure you are the customer. Do not take the one that is more expensive, right? Very important, right? So that's at some point the way we can decide, whether or not you can do something like, you can buy box of 150 Sharpie pens for $165, right? Or a dozen for $13.50. Again, this is the same type of thinkings, box of pens. You buy a box, you can buy a box of 150. Okay? So if you buy, let's say B, you buy 150 for how many? 150. We said that costs $165. But you also can do a dozen. A dozen has how many? A dozen for how much? $13.50. All right. So which one you think is a better deal then? Well, the first thing is to find the price per unit. Find the price per unit. So for the first one, to find the price per unit, you can do 165 over 150. 165 over 150, that's the pen would be $1.10 per pen, right? Now, for this one, you're gonna have 13.50. What is a dozen? A dozen is 12. When you do these divisions, it's gonna give you $1.13 per pen. So better deal would be what? Yeah, the box of 150. Box of 150 pens is a better deal, right? So that's it's all about system units, even though you see that we're doing something different here that by doing the conversions anyway. But you know what? The international, because as we see for the US system metric of measurements, US system or US customary system of measurements, you see this is something we use all the times in the US, but at the same times, that's not the only system that exists in the world. The international metric system was invented in France late in the 18th century for two primary reasons. So that's what they said, to replace many customary units with just a few basic units and to simplify, conversions through use of a decimal base 10 system. So we said the basic units of length, mass, time, and volume in the metric systems. When you talk about the length, it's mostly meter, kilometer, and those are the, you know, for the length, mass is kilogram. You want to know the weight. So that's kilogram. Time is in second. For times, the liter is for volume. So it all depends which systems you want to use. But we have a very special ways of presenting this. But you know what? Common metric prefix for us, we really start with something like ton, quintal, you know, gram, megagram, kilogram, hectogram, decagram, gram in itself. decigram, centigram, and milligram. So it all depends of what we want to do. We can construct a tables. I'm gonna try to draw one table for you because that's something I learned at a very early age. If I put on, let's put it blank. So remember, we already show you all this prefix. Prefix is what you're gonna. If we need to convert from kilogram to grams, all we need to do is to use those prefix. Remember, we can call megagram. We can start with mega, gram, kilo, gram, hecto, because after kilo, you see we go up, we go like this. Hectogram, so we're gonna do H, G, hectogram. We're going to do decagram, decagram. So we're gonna do deca, all right? We're gonna do decagram, okay? Because DA, so. And of course, we're gonna have gram for the G. We have after this one, we're gonna have decigram, milligram, no centigram, CG, because we say C is for centi, right? Centigram. And we have milligram. So that's the most usable. I'm not gonna use the other ones like microgram, nanogram, picogram. So let's go with those basics. So meaning, if I leave this one like that, if I want to convert a 12 kilogram to gram, all right? Remember G means gram. Okay, if I want to convert 12 kilograms to grams, the first thing to do for me is to put the 2 here. This is 12 kilogram, right? Now, if I want to go to gram, I put a 0, another 0, another 0. So, like mean 12 kilogram equal 12,000 gram, right? If I want to convert 10 gram to milligram, so 10 gram to milligram, remember 10 gram to milligram, I can just go ahead and let me change the color. We can do 10 gram is like this is 10 gram. We're gonna go milligram. This is it. So 10G would be equal to 10,000 millig, right? So we can do it the other way around. For examples, let's convert 5 milligram to gram. 5 milligram to gram, you put the 5 here, you go backwards. This is it. So you put a decimal point. So 5 milligram equals 0.005 gram. So when you have those tables, it makes it much easier for you to convert. I know it's going to take us a long time to do it, but how about here? Convert the following quantities to the indicated units where necessary, round to the nearest part. So we can convert anything we want here to a different unit. So if we said we need to convert 13 liter to quarts, okay, 13 liter to quarts, first of all, we need to know what 1 liter is in quart, okay, or how many quart is 1 liter. So where we're gonna check that, we need to go back to that table right here. Let's see liter in quart. Maybe we have it. Liter. 1 quart is in pain. Right. I'm not sure I see liter here in quart, but it must be somewhere. All right. 1 liter We have 1 quart is 2 paint. 1 paint is 12 ounces. 1 ounce is 2 tablespoons, right? Okay, this one is not complete because it's not there. But anyway, I'm gonna get it from the book because I wanted to show you here. So my table right here is not complete, all right? Yeah, it is just a few of them because you don't have everything, okay? So I need to look at it and make sure we have everything we need, okay? Yes. Okay. Um, yeah, I really thought we have this. Give me a few seconds. I need to look for the other tables because I thought we have this in the tables that we didn't have, but that's fine. Um, all right, so I think I find it. We're gonna go back. We said here that was not here. Okay, they said 13, that's A, 13 liter, 2 quarts, right? So we know at this point, 1 liter, we know 1 liter is equal to 1.057 quart. Remember, I'm trying to get this one. So if 1 liter is 1.057 quart, all right? So how would you think the 13 liter would be? You cannot just multiply this one. For us, we can say if you want to see that, that's a different way of doing it, is 1.1, I mean 0.57 quart. Okay. We know at that point, 13 liter would be X quart. A different ways of doing it, so you can do a cross product. That's a different techniques you can use. That means you know X, we're gonna have that is 13 times 1.057. When you multiply this two, because you have cross product, it gives you 13.7 quart. So 13 liter is equal 13.7 quart. This is the answer, right? And meter to feet, of course, you can do it because if you look at B, you have 3.5 meter. And if you want to convert it to feet, we know 1 meter, okay? I would say 1 meter is 3.28 feet. So I believe you need to check that again in a different system because those systems that you can convert. Oh, I'm sorry. I think I have it, but I put it somewhere down here. Maybe. I wonder why I didn't have that one here. Let me verify something from my notes at some point and make sure that this table, I have it. I think I'm gonna come back and insert a slide right here. Now I know why I didn't have it because I didn't include it. So this is the table we were looking for, right? Here we go. All right, now you have it. That's the one I was supposed to use before. 1 quart, we, we go 1 liter is 1.057 quart. Okay. Now, the next exercise, I'm going to put it right there for you to see. Okay. The next exercise in this one, we said B, you're going to convert meter to feet. Let's go back here. 1 meter, this is it. 3.28 feet. So what 2.28 feet? So all you need to do is take 3.5 meter and you multiply it by 3.28. So answer with your calculator, 3.5 times 3.28 give you 11.5 feet. All right. And of course, you can go back to this table. Apologize for not including this table earlier. That's why it takes us so long. So this is the conversions because you can go from US system of measurements, to the international system of measurements. Remember that we can carry conversion between these two metrics, like any other unit conversions, right? So this table really gives you a few handy conversion factors. So it's usually useful to memorize approximate conversions, particularly if you plan to travel internationally. You need because that just you cross the US border and go to Canada, for example, they don't use miles, they use kilometer. In Europe, they use kilometer. They don't use Fahrenheit elsewhere. US use Fahrenheit, but we know elsewhere they use Celsius. So it's really important to know how to move from one to another. A baby born in the US would be in pound and ounces, and somewhere else it would be in kilo. So it's really good to find out about this because, again, if you want to construct a fence around your backyard, you're looking for feet. How many feet do you want? So somewhere else they would ask you how many meter do you want. So it all depends where you're located, and you would need that. As I speaking about temperature units, it's extremely important if you're planning on traveling elsewhere to know this. All right? It's really, really important. That's another important set of standardized units that we use to measure temperature. So three temperature scales that's commonly used. The first one is the Fahrenheit scales, commonly used in the US. Is defined so that water freezes at 30 degrees Fahrenheit and boils at 212 degrees Fahrenheit. But the rest of the world, beside the US, I know Canada, right when you cross the border, or Europe, or the Caribbean, anywhere you go, or Africa, they use Celsius, all right, scales, which place the freezing point of water at 0 degrees Celsius and the boiling point as 100. So when you talk with someone who live in Canada and they tells you they have minus 30 degrees, remember that negative 30 is negative 30 degrees Celsius, right? So it's negative 30 degrees Celsius. But if you have negative 30 degrees Fahrenheit, you are it's terribly cold, right? It's really, really cold. So that's why in the US, you can expect to see snow at 30 degrees Fahrenheit or 20 degrees Fahrenheit, but in Canada, if you said 30 degrees Celsius, it's extremely hot, right? Now, beside that, another one beside Fahrenheit and Celsius, as we said, because there are three temperature scales that we commonly use. In science, all right, in science, we use the Kelvin scale, so which is the same as the Celsius scale, except for its 0 point, which correspond to negative 273.15 degrees Celsius. That's in temperature of 0 Kelvin is known as absolute zero because it is the coldest possible temperature. So remember, we don't use the symbol degrees for Kelvin. We just says Kelvin, right? So I believe you see those here, the units, the three of them, Fahrenheit, Celsius, Kelvin. So it's really getting extremely freezing at 32 degrees Fahrenheit or 0 degrees Celsius or 273.15 Kelvin. So you can boil water with a temperature of 212 degrees Fahrenheit or 100 degrees Celsius or 373.15 Kelvin. But absolute zero, just imagine your Fahrenheit goes, you know, down to negative 459.67 degrees, right? That's very important. Other things you need to see here, zero is not an inherent zero, right? So some zeros mean nothing. Like I have zero siblings, no siblings. I have $0, no dollars. But if the temperature in my area is 0 degrees Fahrenheit, that means it's extremely cold. Now, we said the definitions of these three temperatures is in these tables. You can convert from Celsius to Fahrenheit, from Fahrenheit to Celsius, from Celsius to Kelvin, or from Kelvin to Celsius. Please, anytime do not hesitate to use this formula if you have Celsius and you want to convert to Fahrenheit, or if you have Fahrenheit, you want to convert to Celsius. Anytime, I know it's only for science we use Kelvin, but in real life, the one you do every day out there working with your neighbors and everyone, so you're gonna use Celsius and Fahrenheit. Now, convert, it all depends. If I have Fahrenheit and I need to convert to Celsius, remember Celsius is F minus 32 over 1.8. So for F equal 45 degrees, we're gonna say C would be 45 minus 32 over 1.8. So how many degrees Celsius would be 45 degrees Fahrenheit? So those are the things you really need to figure it out because we're gonna use them all the time. All right. So if I go and use my calculator, let me use my calculator. That will be 7.2 degrees Celsius, right? I could convert also, let's convert also, for example, 20 degrees Celsius to Fahrenheit, right? If you do that, we know the formula for Fahrenheit when you know Celsius is 1.8 Celsius plus 32. So that means the Fahrenheit would be 1.8 times 20 plus 32. How many degrees is 20? How many degrees in Fahrenheit is 20 degrees Celsius, you know? So if you 20 degrees Celsius, let's see what would that be? Uh, 20 degrees Celsius would be 68 degrees Fahrenheit. So 20 degrees Celsius is 68 degrees Fahrenheit. So, and we can convert all of them. Remember, we have different formulas. It all depends of what they ask you to do. If they said, for example, C, convert 240 Kelvin to Celsius, and what's the formula to convert Kelvin to Celsius? We know Celsius would be, uh, you know, um, Celsius would be, the formula is K minus 273.15. So we're gonna have C would be K is 240 minus 273.15. If you have 240 Kelvin, 240 kelvins would be 33.15 degrees Celsius. So that's very hot, right? And etc. If we take an example in B, if you have negative 40 degrees Celsius to Kelvin, remember CD is in Kelvin, so what's the formula for Kelvin? We said Kelvin in Celsius is C plus 2.73.15. So K would be C is negative 40 plus 2.73.15. Kelvin would be what? So if you have negative 40, that would be 3233.15 Kelvin. Remember, we don't put the degree sign for Kelvin, right? We don't put the degree sign. All right. Believe you can use a lot of these examples again, especially when you have to complete your assignments. But in the meantime, sorry about it. In the meantime, we can continue to enjoy those exercises. Let's do a few other ones that especially cover the unit of energy and power, because there's a big difference between energy and power. Maybe you will never pay attention to that because we're now ready to extend unit analysis to problem involving energy, density, and concentration. We'll start with energy, which is a familiar very familiar to all of us because we pay energy bills to power companies. We use energy from gasoline to run our cars, and we argue about the best alternative source to replace the energy we currently get from fossil fuels. But what is energy? Broadly speaking, energy is what makes matter move or heat up. We need energy from food to keep our hearts beating, to maintain our body temperatures, and to or walk or run. A gasoline powered car uses energy to move the piston in its engine, right? Which turns the wheels. A light bulb needs energy to generate light, right? Of course, for Americans, for everyone, the most familiar energy unit is the food calorie, right? That we use to measure the energy of our bodies, then draw from food. A typical adult use about 2,500 calories of energy each day. So the international metric unit of energy is the joule. So 1 calorie, you can say 1 calorie is equal to how many joules again? Because joules is the international measures, 4,184 joules. Please, you can keep that one and put it somewhere because we might need it later, right? But as I said, uh, energy and power, they're not the same because the words energy and power are often used together, but they are not the same. Power is the rate at which energy is used, right? Which means it has units of energy divided by time. The most common units of power is the watt, right? So that's what we do here. So define as 1 joule per second. 1 watt equal 1 joule per second. You know, on utility bills, electrical energy is used, measures its units in kilowatt hours, right there. A kilowatt hour is a unit of energy. All right. We call that the hyphen implies multiplication though. So 1 kilowatt is 1,000 watts, which is 1,000 joules per second, right? So that's why you see 1 kilowatt hour is 1,000 per second. So if you put, remember how many, 1 hour, how many seconds is 1 hour again? Yes, 3,600. Then if you multiply it with 1,000, it gives you 3,600,000 or 3.6 millions. Um, I know it would require maybe more works for you to go over and do these examples again and again and again. But we're gonna try on examples very quick. I know the times. I cannot record for more than 40 minutes. I'm hoping we don't reach it. We said your utility company charged 13 kilowatt hour, kilowatt hour of electricity. What is the daily cost of keeping 100-watt light bulb light for 12 hours each day? So that's quite a very important exercise. Is we're gonna do some computation in order to compute the cost. Okay, we need to find the energy used by the bulbs in kilowatt hour. Okay, and then we would convert it to cents, right? Because this can be done in a single chain of units if we want to, because well, they said 100-watt, right? Bulb, light bulb, or okay, 100 light bulb, like one day will cost 100 for one day. What is it again? One day it will cost what again? Because they said 100 light bulb for 12 hours, right? Because we're dealing with hours here. For 12 hours, we're gonna take the 100,000, 100 watt. Let me write it down here for you to see. Okay, we have 100 watt. Well, actually, 100 watt, we're gonna do it 12 hours per day. Let me put day like this so you can see it, right? 100 watt per day. You would see how many watt again it's gonna be per day, right? So 100 watt per day. Remember, our goal is to convert it because we said in order to answer questions like this, all right, we need to put in kilowatt. So what is 1 kilowatt in watt again? Oh yeah, I said kilo in the previous examples here. Okay, I put kilo, hecto. If you wanna do kilowatt, you can say okay, megawatt, kilowatt, hectowatt, decawatt, watt, all right? So we can go like this, deciwatt, centiwatt, and milliwatt, right? If we want, you can do like this and convert. I put this one for you so you can see. If we want to convert 1 kilowatt to watt, this is right here. We have here 1000. So 1 kilowatt would give you 1000 watt. So this table is really amazing. Once you understand it, all right, you can do that. So we know 1 kilowatt is 1000 watt. Very important to put all of them when you do it here. So we said times 1 kilowatt in watt. All right. Now, first of all, we know we're gonna do 100 watt for 12 hours a day times 1 kilowatt over 1000 watt. As I've said, we're gonna do everything once. Okay. And then we would multiply. We know it costs 13 cents, 0.13 over, they said your utility company charge you 12 cents per kilowatt hour. So 13 cents per 1 kilowatt hour, Now, all you need to do is multiply, and you can see what would be gone. All right. You remember you have so many things that would be gone here, and what you're gonna have left. Okay. So everything would almost gone. So when you do 100 times 12 times 0.13 over 1000, when you do all of this, it would cost you 0.156, or you can say, or about what? 16 cents. It's going to cost you, you know, to light 12, 100 light bulbs for 12 hours a day. That's what it's gonna cost you. 25 bulbs, they said how much will save you in a year if you replace the bulb with an LED bulb that provide the same amount of light using only 25 watts. So 25, now if you do it for only 25-watt bulbs, first of all, we said to like 100 watt light bulb for 12 hours a day is gonna cost us 16 cents, all right? But now, if you replace it with LED, sometimes it's way better. That's according to people who use it. We're gonna take the 25 watt and we're gonna do exactly the same multiplication. 12 hours per day for one day, okay? And what is the cost again? Because we're gonna do 1 kilowatt is 1000 watt, and that's cost us 13 cents per 1 kilowatt hour. So again, if you do all of this, it should give you 0.039 dollars. So about 4 cents, right? Yeah, it's about 4 cents. It would cost you, it's way better to do LED anyway. So LED would definitely be better. So you would save what you would save so far. Let's see about what you would save because they said for 1 year. Now we have it for one day. You will save what? Let me change the color so you'll see where we go. The question so is about the saving. You will save for one day, right? You would save like 0.156 minus 0.04. No, let's get 39 because I used the original number. 0.39, and you're gonna multiply it with 365 days because they said for 1 year. 1 year has six. That was for one day if you do it for 1 year. So that would be what you would save, $42.71 over a year. Okay? If that's okay with you, it's okay with me. So definitely, I'm fine with that. Last exercise, probably leaving it for you to enjoy because I like when you take time to look at some of these exercises. What I would like you to do is look at number 6 and try to do it on paper. If you get stuck on it, you're gonna ask me questions. But remember, those type of exercises, you can do part A to D with no problem. Because for this one, what they ask, the questions is really about the 222 Hyundai Ioniq is rate 25 kilowatt per 100 miles, right? So it's electric, right? Requires to drive 100 miles. So, or 1 kilowatt for 100 miles. How much energy is required to drive this 150 miles? So those are the type of questions you're gonna ask. All you need to do, remember 100 as a tips. Remember, you do 150 miles. If you follow the same way, it tells you here you can do 25 kilowatt hour for 100 miles. And the question was how much energy in kilowatt hours is required to drive this Hyundai. But once you do that, you can multiply and see because they ask you for kilowatt hour. So multiply 150 by 25 and divide by 100. That would definitely give you 37.5 kilowatt hour. So how much energy is required to drive 150 miles? It's required 30.7 kilowatt hour, right? To drive 150 miles, right? And we can diversify the questions as we see. If you do 80 miles now, they give you price because they said assuming electric cost is $12 by kilowatt hour, how much it would cost. You do the same to how much it would cost to drive 80 miles. Again, from the previous example, we said if we take 80 miles, we multiply it by the information given times how much money again? Yeah, 12 cents times 12 cents for every 1 kilowatt hour. So when you do that, it will cost you only $2.40. And of course, as you see, the other examples would be the same, right? But only leave you to do C and D for now. I hope that's helped. Let me know if you have any questions. I'll definitely see you in the next video. Take care.